Today we're going to be doing a lab called Half-Life of Pennium. So what we're going to do is we're going to use pennies and the fact that they have a 50-50 chance of being heads or tails, and we're going to use that probability in order to simulate half-life. So the lab is broken up into two halves. We have our expected results, which is pretty simple. At 0 half-lives, the fraction remaining would be 1/1, and the percent remaining would be 100%. Theoretically, so if things worked perfectly, after 1 half-life, your fraction remaining would be 1/2, and your percent would be 50. You can do the rest all the way down to 7 half-lives. Now, here's where it comes in. Here's where the actual lab comes in. So you're going to get a dish, okay? And the first thing you're going to have to do is count the number of pennies in the dish. So an example would be this. You're going to count all of those pennies. Now, what I'm going to do is I'm going to put them out and spread them out and take a picture and let you count them. So let's just say, theoretically, let's say there was 150 pennies, right? So put a little squiggly line in because your number isn't going to be 150. It could be however many are in this dish. I don't know. Okay, but this number is going to be your total the entire time, and it's not going to change. Okay, the total number of pennies isn't going to change. What's going to change is the heads and tails. So what you're going to do is you're going to split these into, so you're going to shake them up and pour them out and split them into heads and tails. All right, so that's pretty simple. And then what you're going to do is we're going to assume that at half-life 0, we're going to assume all 150 of them are heads and 0 of them are tails. That basically means you have 150 undecayed pennies. You're going to put them into the jar, you're going to shake them up and dump them out, and theoretically, I'll put little squiggles in front of these lines, you're going to get 75 heads and then 75 tails. What you're going to do is you're going to take the undecayed, and they're going to get put off to the decayed pennies get put off to the side, and the undecayed still haven't given off their radiation, so they still can have a chance to do that. So what you do is you take the undecayed pennies, put them back in the dish, shake them back up, spill them back out, separate those into 2 piles. So let's say now you get, let's say you have 40 heads or undecayed pennies left over, right? Again, these are approximate numbers. I don't know your exact numbers. Let's say you have 40 heads left over, right? Your tails pile is not going to be 35. That's a common mistake. It's actually going to be 110 because you had 35 out of the 75 went tails, but there was also 75 tails from the previous run, and so they got added together. And so what's going to happen is this number is going to get smaller and smaller and go down to eventually 0 or 1 or 2 or 3 or something like that. And then this number is going to get bigger and bigger and bigger, and it's going to eventually end up at around, 150. It might not be exact. It might be 1 and 149. It might be 3 and 147. You don't really know until you look at the pictures. And again, just remember, I used 150 as an example number. These, you're gonna have to count them out every time, and you can't just half them because these are real pennies, so it might not be exactly half. It might be a little more or a little less. Same thing every single time. So you really have to go through the pictures and take a good count. The questions are pretty simple. How are the pennies simulating half-life? I already mentioned that. How are pennies different from real radioactive decay? So things that actually give off radiation, which is dangerous to you. 3 is just a half-life problem. Show your work. Make sure you draw out your chart. There's probably not going to be enough room, but remember you're going to have, number of half-lives. It's always going to start with 0 and 0, time, and then mass, and then this goes 1, 2, 3, and onward. So you're going to use that chart for 3. You're going to use it for 4. You're going to use it for 5. For number 6, you're going to graph your results. So remember, there's going to be 2 lines on this graph. You're going to have the red line for undecayed, which is going to start out really high, and it's going to go almost down to 0. And then you're going to have your decayed ones, which is going to start out at 0 down here, and it's going to go up and over. So you're going to have 2 graphs, and they're going to look, something like one goes up and over, and the other kind of goes down and out, kind of like that, but I'm going to let you graph them. And then you're going to color them red and blue. And then the next couple questions, 7, what's happening to the number of undecayed? That's basically, that's right from the lab. What's happening to the number of decayed? That's from the lab. What's the cause and effect? Meaning what's the relationship between total number of pennies and decayed and undecayed? And you can explain that relatively easily. And then that's everything you need from this lab. The rest you're going to get, the data you're going to get from the photographs, which I'll post with this lab, and then you're going to fill everything out and answer the questions on your own.